Hello, my name is Wayne Fensky. I'm with the KPU Philosophy Department, and I will be teaching this class, Philosophy 1150, Introduction to Formal Logic, for the summer 2020 semester. Let's start off by considering some of the details on the class syllabus. A PDF copy of the syllabus is posted on the class homepage. There are two different sections taking this class, Section S10 and Section S11. I've called it Basic Logic Summer 2020. Instructor Dr. Wayne Fensky, feel free to call me Wayne. If you ever need to contact me, the best way is by my email address, wayne.fensky@kpu.ca. Office hours, for now I'll start off setting them Monday to Saturday at mutually convenient times. If it turns out that there are so many people seeking office hours throughout the summer, I may have to put some constraints on when I'm available, but generally speaking, there's not that many people that it's worthwhile to put constraints on them that make it more inconvenient for certain people. So I'll leave it the way it is for now. Text. There is no formal textbook in this class. Rather, there's going to be a set of video lectures on YouTube. They're going to be the main source of instruction for this class. The videos are going to be labeled as follows. So the first one, the one you're watching now, is going to be called WF Basic Logic L1. The next lecture, WF Basic Logic L2, and then the one after that, WF Basic Logic L3, and so on. So I've labeled the lectures this way so that they can be easily accessed through the search function within YouTube. There is some mechanism so I could upload the YouTube lectures through the Blue Button software at Quantland, but this strikes me as being unnecessary, and if the Quantland system crashes, which is possible, then we're going to be in some trouble. It's much easier, I think, if I just give you the easily accessible YouTube addresses. The lectures will all be sequentially numbered. All you have to do is make sure you watch the appropriate ones. Before each of the four tests, which we will be getting to, I'm going to indicate to you by email which lectures you have to make sure and watch, and which exercises you have to make sure and do. Now, we're in a situation where I'm making new video lectures as the semester goes on, so I'm not really certain how many there will be. I would guess between 25 and 30. There may be even less than that, there may be more than that, but I think it's probably somewhere around there. And each of these lectures will be approximately an hour in length. Now, here's the setup for this class. To succeed in this class, you're going to have to, 1, be familiar with a range of theoretical material and key logical concepts that sets out the underlying rationale for the various exercise questions that you'll be working on throughout the semester. The second thing is to instill a deeper practical understanding of how to carry out various logical computations successfully, and this is best achieved by actually doing those exercise questions. So, regarding the first part, the theoretical and conceptual learning part, since there's no formal textbook, it's extremely important for you to watch every video lecture carefully and to make sure that you understand the concepts, methods, and rationales that are explained in each one. You will need to pause each video lecture several times so that you can write down appropriate notes. The reason I do this is that students learn material better by thinking about and writing out their own notes instead of just having pre-made notes handed to them that they might skim over more quickly than they really should be. So part of the theoretical and conceptual learning task will consist in writing out a comprehensive set of notes that summarizes the material presented to you in the videos. The second, and in many ways most important part of the class, though, is the deeper practical learning, and that only comes when you're actually doing questions from the exercises. And you're going to need to spend at least 2 hours per week doing questions from the exercises. That is, in addition to watching every video lecture carefully and taking comprehensive notes. There's a file on the class homepage, in addition to the syllabus, that's simply labeled Some Notes and Exercises. So this file contains all of the exercise questions you're going to need to complete in the first half of the semester. Exercise questions for the second half of the semester are going to be posted a little bit later. And solutions for the exercises are going to be put up on the homepage a little bit after I actually explain the material. So in other words, I'd like you to try to do these exercise questions on your own before I provide the answers to you. But you will certainly receive the answers well before the tests on that material. This file, the file Some Notes and Exercises, also contains a few helpful notes, which are very basic. These notes do not cover all of the material presented in the video lectures and are not intended to replace them. All right. Finally, please contact me by email if you have any questions about issues arising in the class. If your question requires a prolonged answer, please provide a telephone number. I will also be available for office hours by telephone at mutually convenient times. If you wish to arrange an office hours appointment, please provide a telephone number and convenient times to be contacted. Finally, here's how the grades will be allocated. Course grades will be assigned on the basis of the following 4 components. So we've got 4 tests that are worth 25% each, and I've spaced them out equally throughout the course. So one's near the end of May, the second one the latter part of June, the third one in the middle of July, and the last one, which is in a registrar scheduled final slot, is in the middle of August. Rather than saying anything in more detail about those tests now, I'll just point out that you're going to receive a PDF copy of each exam at 10 a.m. on the day of the test, along with the instructions for completing and returning that exam as an assignment on the Moodle homepage. Some of you may have done this already. Specific information regarding the types of questions that will appear on each of the 4 tests will be given before each test is written. By and large, though, the 4 tests will just be samples of questions, not exactly the same, but like the questions in the exercises you've been doing. The first test is a little bit different because for the first part of the course, I have to explain what logic is all about and what the point of the various exercises we're going to be doing is about. So there's going to be questions in addition to ones that are just like the exercises. That being said, we can now consider what a course like this is all about. So, what is logic? This is kind of a funny question to ask because if you think about it, You've probably kind of known the meaning of that word since about grade 4 or grade 5. Everyone has got a basic understanding of what the word logic means. And so, for that reason, when you ask the question, well, what exactly is logic? It's a little bit of an odd question. People have a general idea of what that word means, but maybe they don't have the kind of precise understanding of what that word means. So for what we're going to need here. So I'm going to start off giving you some fairly abstract points, and afterwards we'll return to consider some concrete examples. So, for the purposes of this class, logic is the systematic analysis of the form or underlying structure of arguments. So that's why this class is called Introduction to Formal Logic. Formal logic is the study of forms or underlying structures of arguments. Now, what we're going to see in a class like this is a fair number of everyday words have technical definitions that are a little stricter than we're probably used to. So, the next thing to consider, what exactly is an argument? Once again, everyone knows what an argument is. If you ask yourself, what would be a good example of an argument? Usually there's going to be yelling, displays of emotion, stuff like this. People are having some sort of disagreement. But for the purposes of this class, an argument is a set of sentences with an evidentiary structure. What do I mean by that? Well, an argument is a set of sentences, but not just any set of sentences. It's a set of sentences that divides into two parts. And with any argument, all but one of the sentences in that set function as evidence or proof of the remaining sentence. So, for arguments, you've got the provers on the one hand, the evidence providing sentences, and then you've got the provee, or the sentence for which evidence has been provided. The provers are what we call the premises of the argument, and we can sometimes think of the set of provers as the premise set, and the provee is just the conclusion of the argument. So, logic is used to determine whether or not a given set of premises, a given set of evidence providers, provides a good case or sufficient proof of a particular conclusion. So another way of putting it, what we want to do in this class is learn some systematic methods for distinguishing between good or convincing arguments and bad or unconvincing, or we might even say less than fully convincing arguments. And the question is always going to be, does the evidence for the conclusion establish that conclusion, or does it fall short of establishing that conclusion? So we're going to be learning some methods for making such determinations. One last thing before we move on to concrete examples, very important to be aware that there are two different flaws or shortcomings that any argument can have. On the one hand, an argument can always have an informational flaw. When an argument is informationally flawed, the situation is such that one or more of the premises or evidence providers is false. In that case, you're providing evidence for a conclusion, but your evidence is inaccurate. And if that's so, then you haven't provided a strong case for the conclusion. The second way any argument can go wrong, and this is the one we're going to focus on, is that an argument can be logically flawed. So, when an argument is logically flawed, the premises don't establish the conclusion. Or another way of putting it, even if you accept the truth of all of the premises, even if you agree that all of the evidence providers are true, if an argument is logically flawed, it's still reasonable to doubt the truth of the conclusion. All right, so all of this is a little bit abstract perhaps. Think about this though carefully. Make sure you pause the video and write this down in the words that I've put. It's also often helpful to add sentences in your own words to this. And then we'll consider some concrete examples of what I'm getting at here. Here are three concrete examples of very simple little arguments we can consider. So, I've got the two premises of the argument, the two provers, numbered and separated from the conclusion of the argument by a horizontal line. So, the first argument, which we'll call A, goes like this. If you're in Kelowna, you're in British Columbia. You are in Kelowna, therefore, you're in British Columbia. What do we make of this argument? Well, given that we're watching this instruction on videos, I suppose it's possible that there are people out there watching this video from Kelowna. But I'm assuming for pretty much everyone, the second premise is false. That is to say, there's a clear informational problem with argument A. Argument B says, if you're in Victoria, you're in Wyoming, the American state. You are in Victoria, therefore you're in Wyoming. This argument, which we'll call argument B, is also informationally flawed. It's, so to speak, doubly informationally flawed in that both the first and the second premise are false. As far as the logical analysis of an argument goes, though, we're not interested in how or the degree of informational flaws contained in a particular argument. We're only interested in the question, is the argument informationally flawless or is it informationally flawed? So the first two arguments, A and B, are informationally flawed. What about argument C? If you're in British Columbia, you're in Canada. You're in British Columbia, therefore you're in Canada. And again, I'm assuming that with this third argument, both premises are true, although there may be some viewers who are outside of British Columbia or even outside of Canada viewing it. But for those of us in British Columbia, both premises are true. Now, as far as the logical analysis of these arguments go, though, we can leave all informational issues aside. That is to say, we can assume, for the sake of argument, as the phrase goes, that all the premises in the arguments we're considering are true, even if, deep down in our heart of hearts, we doubt that that is so. So we can provisionally or hypothetically assume that all of the premises in our arguments are true. We can provisionally or hypothetically assume that there are no informational problems in the arguments we are considering. Why do we do that? Because we're naive? Because we're gullible? No, we do that in order to engage in a logical analysis of the arguments we're considering. Because these are two very different, entirely separate kinds of flaws. And what we want to do is focus in on whether or not the argument has a logical flaw. And to facilitate that, we will provisionally or temporarily or hypothetically assume that all the premises in our arguments are true. Now, we're going to find out whether or not the argument has a flaw, and after that, if the argument doesn't have a flaw, we can always go back and drop our provisional assumption that all the premises are true. And we may want to do that if something's really at stake as far as the conclusion goes, and we find the argument to be logically flawless. Now, here's something that's a little bit difficult to set out in words, this idea: what exactly is the form or underlying logical structure of an argument? Be that as it may, though, can you see, just by looking at it, that these three arguments all have one and the same form or underlying logical structure? They all consist of a first premise, which is a type of compound sentence that's called a conditional. We'll see that a little bit later, as well as a simple sentence. The first two arguments, as we noted earlier, have some informational flaws. The third argument doesn't. Here's the key thing, though. Since these three arguments all have the same form or the same underlying logical structure, all three of these arguments are either logically flawless, that is to say, they're arguments of the type where the premises do establish the conclusion. They're arguments of the type that if you accept even provisionally that all the premises are true, it's not reasonable to doubt the truth of the conclusion. So what we're going to do then is focus in on arguments, and what we want to do is determine whether the arguments are logically acceptable or not, and in doing that, we'll bypass this separate question of whether or not the arguments are informationally tainted. Okay, now that we've got that under our belts, we can ask ourselves the following question: what kind of relation has to hold between, on the one hand, all the premises or provers being true, and the conclusion being true. In order for an argument to be, and I'll just put it this way at this point, logically acceptable. So what kind of relation has to hold between all the premises of a particular argument, say argument A being true, and the conclusion of that argument being true, in order for that argument to be logically acceptable? So I'll now set forth a couple of possibilities, a couple of different ways of answering that question. Here's an illustration of what I mean by this question. You'll notice I've neatened it up a little bit. What kind of relation has to hold between one situation, namely all of the premises of argument X being true, and a second situation, the conclusion of argument X being true, in order for argument X to be logically acceptable? Here's a concrete illustration of the issue I'm getting at here. What do you think of the following argument? Two-premise argument again. Different underlying logical structure, though, than arguments A, B, and C. So this is argument D. Rhonda grew up in Winnipeg. Second premise, 99% of the people who grew up in Winnipeg know how to skate. And from these two premises, we have the conclusion, therefore, Rhonda knows how to skate. Now, as always, you might wonder, well, who is this Rhonda? How do we know that she grew up in Winnipeg? How do we know that it's exactly 99% of the people who grew up in Winnipeg who know how to skate? Again, for logical purposes, we can set those informational issues aside and assume for the sake of argument that both of these premises are true. A particular person named Rhonda grew up in Winnipeg, and the second premise, it might be a little bit off, but it's definitely in the ballpark. Now, what I want you to consider is, what's the relation for argument D between all of the premises being true and the conclusion being true? Or another way of putting the question, how likely does the truth of the premises in argument D make the truth of the conclusion? And the answer is that the premises in argument D make the conclusion 99% likely. So, is that a logically acceptable argument? Now, one thing at this point a number of people will point out is that with argument D, it's still possible for both of the premises to be true, but Rhonda is one of those few people, 1 out of 100, who grew up in Winnipeg and still didn't know how to skate. So in other words, it's possible for all of our information to be correct, all 2 of our premises to be true, even though our conclusion is false. Does that make this argument logically unacceptable? The answer is, it depends. Let's suppose you had a university club and you wanted to rent an indoor hockey rink in order to have a skating party, and you only wanted people who know how to skate at that party. Not much fun to go to a skating party if you don't know how to skate. And then, of course, there's always the problem of liability. People who don't know how to skate often fall and injure themselves. Should we invite Rhonda to our skating party? Someone might ask. In response, someone else might present the following argument. Rhonda grew up in Winnipeg. 99% of the people who grew up in Winnipeg know how to skate. Therefore, Rhonda knows how to skate. So we should invite her. Sounds like a good argument to me. What we have here is an example of what's often called an inductive or statistical argument. With inductive or statistical arguments, what's under consideration is how likely does the truth of the premises make the truth of the conclusion. And related to this is the question, well, how likely does the truth of the premises need to be in order to, or how likely does the truth of the conclusion need to be in order for an inductive argument to be a logically acceptable one? And that depends on what's at stake. There are a number of issues here. I point this out just to note that there's a whole area of inductive or statistical logic that's entirely legitimate, and there are numerous theoretical issues to be considered there, and such issues are considered in Philosophy 1145 at Kwantlen, which is a course on informal logic. So, even though this is a perfectly acceptable argument as far as it goes, a perfectly acceptable or a strong argument from an inductive perspective, it isn't an acceptable argument from what's called a deductive perspective. And this is what we're going to be considering in Philosophy 1150. Another way of putting it, Philosophy 1150 is a course in basic deductive logic. So, with deductive logic, the relation between the premises all being true and the conclusion being true can't just be that the truth of the premises makes the truth of the conclusion very likely, even 99% likely, even 99.9% likely. So, what exactly then is the relation between the truth of all of the premises and the truth of the conclusion that's necessary in order for a deductive argument to pass the logical acceptability test? Remember on this panel earlier there are two issues to be considered with any argument. One, does it pass the informational test? Are all the premises or provers true? We can temporarily bypass that in order to consider the logical issues. Is the evidence presented for the conclusion logically acceptable? So, this argument is logically acceptable from an inductive perspective as an argument in informal logic, but it's not logically acceptable in deductive logic. And this is the logic we're considering here. So, what's the relation that has to hold between the truth of the premises and the truth of the conclusion in deductive logic? Having considered one relation that might hold between all of the premises of argument X being true and the conclusion of argument X being true, namely that the truth of the premises makes the truth of the conclusion likely, or perhaps very likely. These sorts of relations are appropriate when we're considering inductive logic, but they're not appropriate with deductive logic. When we're considering deductive logic, the key relation between 1, all of the premises of a particular argument being true, and 2, the conclusion of that argument being true, is one of necessity. This is the key relation in all of deductive logic. So, when an argument is logically flawless, or, and here's a technical usage of this word, valid, and here are two different ways of saying the same thing. So the first one, A. If all the premises of a particular argument are true, or were all true, the conclusion has to be true as well. A second way of putting it is to say that it's impossible for all of the premises in a valid or logically flawless argument to be true and the conclusion false at the same time. So this is the key relation that underlies all of logical analysis. Does the truth of the premises necessitate the truth of the conclusion, or doesn't it? There's only two possibilities. If the truth of all the premises necessitates the truth of the conclusion, then the argument is valid or logically flawless. On the other hand, if the truth of the premises doesn't necessitate the truth of the conclusion, or another way of putting it, it's possible for all the premises to be true and the conclusion false, then the argument is invalid or logically flawed. Now, it's key to realize that all of the premises in a particular argument don't have to be true in order for this all-important relation of necessity between the truth of the premises and the truth of the conclusion, this relation that we refer to as validity, to hold. So, let's return to the first three arguments we considered. In the first one, it happens to be the case that the first premise is true and the second premise is true as well. The first premise is true as a matter of geographical fact. If you're in British Columbia, then you're in Canada. For all of us who are watching this video in Canada, in British Columbia, it's also true that we're in British Columbia. Now, does these two things being true necessitate the sentence below the line being true, or is it possible for these two sentences above the line to be true and the sentence below the line to be false? Here we have a situation where the argument itself, or the structure or form of the argument, is simple enough that you can tell just by looking at it, just by thinking a little bit about its implications, that it's not possible for these two sentences to be true. If you're in British Columbia, you're in Canada, and also you're in British Columbia, and at the same time for it to be false that you're in Canada. So in other words, both of these premises are true, but that's an informational issue. The important logical issue is that the truth of these two premises necessitates the truth of the conclusion. Now, we turn to argument B, where the two premises are both false and the conclusion is false as well. But this is an example of an argument that is informationally flawed, but it's still logically flawless. Why is it logically flawless? Because the premises are true? No, they aren't true. It's logically flawless because if all two of those premises were true, the conclusion would have to be true as well. It's not possible for these two premises to be true and the conclusion false. The same considerations hold for argument A. Even though the second premise is false, if these two premises were true, well, the geographical fact that Kelowna is in British Columbia is true, but if it were also true that you are in Kelowna, it's not possible for these two things to be true and the sentence below the line to be false. That's what makes argument A a valid or logically flawless argument. So this is the issue we are going to be learning how to determine throughout the course. Does the truth of the premises or evidence providers necessitate the truth of the conclusion being argued for? Either it does or it doesn't. If it does, then the argument is valid or logically flawless. If it doesn't, then the argument is invalid or logically flawed. Very important to realize that the premises don't have to all be true in order to make a validity determination. So we're coming to the end of our first video in Philosophy 1150. At the risk of repeating myself and telling you things that you already understand, I'm going to end this first video by noting the following. Whenever you're presented with an argument, someone is trying to convince you that a controversial claim is true, and the way they're going to try to convince you is by providing evidence or a case for that claim. There's two different possible problems that can arise with any case or evidence or argument that's given for a controversial claim. First of all, there could be some misinformation problem. The case that the person's presenting you could contain one or more false claims. The second potential problem area, and this is the one we're going to focus on in this class, is that the evidence that's provided to you may be all true, but even if it is, it's still reasonable to doubt the conclusion. When we're considering this issue, we're considering the logical aspects of the argument. So we can look at it this way. The premises or individual evidence providers in some argument presented to you may or may not all be true. You don't have to ascertain whether or not all the premises are true in order to make a logical analysis of the argument. And in fact, once you become skilled at making logical assessments of arguments, it's quicker and easier to do the logical assessment first. If it turns out that the argument's logically flawed, then you don't have to bother determining whether the premises are all true, because it's already a bad argument. If the argument turns out to be logically flawless, though, then there's just no avoiding it. You either have to accept the truth of the conclusion, Or you have to demonstrate that one or more of the premises is false, and that might take some real research work. Or, I suppose, you could always just be irrational and respond that even though a perfectly convincing case has been presented to you and you're unable to point out any errors in that case, you're still going to stubbornly refuse to accept the conclusion that that case demonstrates. As far as I know, no one's going to throw you in jail for being irrational, but if you want to evaluate information rationally, those are the only two potential flaw areas that you can focus on in an argument. So, someone presents an argument to you for a particular conclusion. The premises in that argument may or may not all be true. The logical issue is that if the premises were all true, they might already be, or you might have to suppose that they are, even though you doubt that. But if the premises were all true, would that, and here's the two different ways of making the same claim, necessitate the truth of the conclusion as well, or make the falsity of the conclusion impossible? If so, then the argument is valid. If not, then the argument is invalid. Okay. So, in the next video, we're going to focus in on the form or underlying logical structure of the various arguments that we're considering. And to enable us to do this, we're going to symbolize all of the individual sentences in that argument. So the point of symbolization is to make validity assessment easier and more straightforward. So we're kind of going to leave the notion of validity to the side for just a little bit in order to focus on this task of learning how to symbolize the form or underlying logical structure of various arguments accurately. But before we do that, I just want to emphasize the point of symbolization is to make validity assessment easier and more straightforward. Okay, just a couple last points here. One, sentences can be true or false, but sentences can't be valid or invalid in the technical way in which we're using that notion. You have to keep in mind that many words have a range of different meanings. With the word validity or valid, I think the most common meaning is plausible or correct. If people are having some sort of debate and someone makes a claim against another person, the response might be, well, that's a valid point. The word valid there isn't being used in the same technical way that we're using it in this class. And arguments, on the other hand, can be valid or invalid, but they can't be true or false. It doesn't really make sense to say that an argument is true or false. It only makes sense to say that the argument is valid or invalid. Sentences can be true or false, but they can't be valid or invalid in the technical sense in which we're going to use it. One last thing to say about this technical sense of the word validity. Validity is a subtle notion that enables us to logically evaluate arguments in order to separate good ones from bad ones. What is validity? Do all the premises have to be true in an argument in order for that argument to be valid? Answer, no. Does the conclusion of an argument have to be true in order for that argument to be valid? The answer, no. Validity is a notion that describes a relation between the premises all being true, which they may not be, and the conclusion being true, which it may not be. Validity focuses in on the issue, if the premises in an argument were all true, which they may not be, would that necessitate the truth of the conclusion as well, make the falsity of that conclusion impossible, or not? That's the fundamental question that we're going to focus in on here. I'm repeating this at length because I know from past experience, validity isn't a super complex notion, but it's a little bit subtle. And it takes some people a little bit longer to catch on to exactly what we're getting at. So with that in mind, in our next video, we will move on to consider how to symbolize individual sentences, and once you've symbolized all of the individual sentences in an argument, you've then symbolized the argument. And just to repeat one last time, the point of the symbolization we're going to be learning in the next video is to make validity assessment easier and more straightforward. So, in a few days we will have the second video in the Philosophy 1150 Summer 2020 class.